All right, guys, what's going on? Sorry, this is a little bit late again. But first thing, guys, check over your grades. They all should be updated. I'm still missing out of all my students, about half of you guys didn't even do your Kessel Learning. So that is, again, moving forward, just not, things are due Friday. I'm not giving a lot, right? The only time I'm going to give Castle Learning is at the end of the unit. So make sure you get that in because that's going to be a little bit more of a grade than your other assignments. And the other assignments are pretty straightforward. So just a reminder, you have Tuesday, Wednesday, Thursday station model practice. Ask me any questions you want, right? If you need help, I can do another video showing you, how to do it. But just watch the video. You're really just looking at your reference tables and do those key points. One thing that you should see difference between yesterday's station model and today's station model is you should see that the temperature and the dew point are closer together because guess what's going to happen later? It's supposed to rain. So when it's raining, the temperature and dew point should be the same. So the temperature and dew point come closer together, more likely precipitation, spread apart. It's going to be drier out. So we're going to get today into fronts, and what a front is a boundary interface between air masses. So if you have a cold front coming in, behind it is a cold air mass. If you have a warm front coming in, behind is a warm air mass. We have different types, and if you look on your reference tables, you have stationary, right, and then occluded. Also, but we're really going to focus on the cold fronts and the warm fronts and what's associated with them. So um, the the rule is the triangles and bumps always point the direction the front is moving. So right here we see A. Right here, that's a cold front. Think of icicles to remind you of cold front. It's moving south. All right, and you have all these different types of fronts. Is just whichever way they're going. That's the front of the front, and it's moving in that direction. Now, big thing with cold fronts, and I touched on this because we had a couple thunderstorms over the last couple of weeks. Right, that's a cold front coming through, right? And it kind of moves through like a plow. And what the reason you have thunderstorms associated with the cold front is because the air rises very quickly, right? It rises very quickly, and when it rises quickly and fast, you have a lot of energy there. You have a lot of uplift. Everything associated with weather in the atmosphere has to do with convection currents, right? Warm air rises, cool air sinks, and when it rises quickly, right, clouds develop, and you have friction occurs, right? A lot of particles are bouncing off of each other, and it builds a charge. So think about if you're rubbing your feet on a carpet, and then you touch something metal. You're building a charge, and then it discharges it. That's essentially lightning, right? It's the same type of principle. When the air rises very quickly with a cold front, it builds up a charge, and then it is released, right? And it hits, a tree, or it hits a pole, or it hits a building, right? It hits a boat or something. That's why they say if you're in a thunderstorm, don't be out in a flat area. Don't be under something tall, right? Because you're going to try to find the path of least resistance. So that's all that is. Think about static electricity, rubbing your feet in the carpet, touching something metal. The same thing happens with thunderstorms, that cold front coming through. So anytime you have a thunderstorm, the next day, it's going to be cooler. It should be cooler, right? And so cold front, I kind of associate to like Mike Tyson, right? It's a knockout, right? Really close. Think of like an uppercut. It's powerful, right? If you ever watch Mike Tyson's greatest hits, right now he's knocking people out in like 10, 15 seconds. It's very short-lived, right? You can have a thunderstorm. It comes through really quick, right? It can be very severe, and then after it, it's pretty calm. Whereas the warm front is kind of weaker. It's kind of more annoying. It's a warm air mass coming through. You might have some drizzle and some clouds over the next day. It's kind of like a wimpy fight, someone like fighting like this in front of them. It's like prolonged. It lasts way too long. There's no real knockouts, right? And it happens in front of the front, right? So think of Tyson. Cold front happens at the front. Severe weather. Warm front happens in front of the front. Kind of a weak, wimpy fight, right? Someone going like this. Will last way too long and last a few days, right? But the weather's not as severe, all right? So this kind of animation shows you this is a warm front coming through, and the kind of drizzle and kind of not so great weather happens in front of the front, whereas the cold front rises quickly. It's short-lived, but it's severe and happens right at the front, right? And a big thing associated with cold fronts and with thunderstorms is tornadoes. I'm going to touch base on severe weather, tornadoes, hurricanes, and Hurricane Sandy on Monday. Um, But this is a low pressure center. And as you know, we talked about low pressure centers are counterclockwise and inward. And this is a typical low pressure center. You have a cold front chasing a warm front. You can see the bad weather is in front of the warm front, and the bad weather at the cold front is at or a little bit behind the cold front here. And this, again, is how a thunderstorm forms, right? So it's really just uplift, right? You have a cold front coming through. The air rises very quickly, right? It can start to spin, and that can lead sometimes severe thunderstorms. Severe fast uplift can lead to tornadoes. Believe it or not, we do have tornadoes here in Long Island. It's not obviously as prevalent as in Tornado Alley in the Plain States, which I'll talk more about on Monday. But we do have tornadoes here occasionally on Long Island, and tornadoes just like thunderstorm on steroids, right? So you have that updraft, particles are colliding in with one another, right? Building a charge, right? That charge is then released, and that's why we have thunderstorms. We had a couple over the last 2 weeks. We even had 2 weeks ago we had hail, right? You don't really see too much hail on Long Island, but that's something associated with with thunderstorms as well. You can have hail, right? We didn't have too crazy a hail, but hail can be pretty nasty. If you have like some golf ball size or softball size hail, it can do some damage cars, damage structures, and things like that. So that's it. Quick lesson today on fronts, on thunderstorms. Get that work in on Friday, right? I was super lenient, taking all lates, right? But now we're getting, I'm giving tiny little assignments on Monday, and just make sure you get it done by Friday. And any help you need, let me know. All right, I'm here to help you get it done. And then next week we'll talk about storms. We'll talk about tornadoes, hurricanes, and then that's it. Then we'll have a end of the unit weather unit, and then we're into our last unit. We're into the climate and environment unit, and then that's it for the end of the year. So I hope you guys are doing well. Miss having you guys in class, seeing your guys' faces, but I hope everyone's enjoying the nice weather and getting outside. And I'll talk to you on Monday. Let me know if you need any help.